Hi everyone. So in this video we are going to start studying about input impedance. But before that you just answer a very simple question. 5 kind of impedance are written. You let me know whether it is resistive, inductive, capacitive or complex. Okay. So this is a resistive, right? I hope you already know it. This is inductive. Why is that so? Because the impedance provided by the inductor is j omega L and the impedance provided by the capacitance is 1 by j omega C. If I take this j upward, what it will be? Minus j by omega C. So whenever you see minus j, that means that is capacitive. If you see plus j, that means that is inductive. So this is your inductive. Because this omega c, omega L, this value will be positive only. 1 by omega c, this value will be positive only. So if minus j is there, that means it is capacitive. This is complex. But in complex, what it is? Resistor plus inductor. Right? And this is also complex. But in complex, what it is? Resistor plus capacitor. Okay, well and good. Let's start our input impedance now. So impedance calculation on a transmission line. So what is the value of input impedance? That is for any transmission line, for any lossy transmission line. We are not taking lossless here. Okay, for any random transmission line, what is the value of input impedance? Z0 into ZL plus Z0 in Zin is equals to Z0 into ZL plus Z0 tan hyperbolic gamma L upon Z0 plus ZL tan hyperbolic gamma L. Just write it down in your rough notebook. You need to remember it. Now, if my ZL is 0, that means if my load is short circuited load. So, what I am going to do? I am going to put ZL equals to 0 here and ZL equals to 0 here. So, what I will be left with? This will be gone. This will be gone. Z0 will get cancelled. So, what will be my answer? Z short circuit is tan hyperbolic gamma L. So, what I am saying? My Zin input impedance when my load is short circuited, that is your Z0 tan hyperbolic gamma L. Say yes or no? Same goes for open circuit. What do you think? What will be the answer for Zin when your load is open circuited? Load is open circuited. That means it is open circuited load. So what will be the answer? What will be your input impedance? So if load is open circuited, that means ZL is infinity. So this guy is very larger than this guy. ZL is very larger than this guy. So this guy I can ignore. This will go to 0 and this will go to 0 because ZL is very large. That means this guy is very larger than this guy. So what I can do is that I can ignore this guy. It goes to 0. And ZL is very larger. ZL is infinity. That means I can ignore this guy. So this goes to 0. And ZL get cancelled. So what is the answer I am getting? Z0 upon tan hyperbolic gamma L. What that would be? Z0 cot hyperbolic gamma L. Right? This is your Zin open circuited. Is that clear to you? ZL is infinity. That means ZL is very high. So this guy I can take equals to 0. Here ZL is very high. So this guy I can take equals to 0. Then ZL get cancelled. So Z0 upon tan hyperbolic gamma L, that can be written as cot hyperbolic gamma L. Is that clear to you? Certainly it is clear. Okay. Now what do you see here? If I multiply both of them, what I will get? Zin short circuit into Zin open circuit. If I multiply both of them, what I'm going to get? Z0 square, right? If I multiply both of them, Zin short circuit into Zin open circuit, then cot hyperbolic gamma L into tan hyperbolic gamma L, that will be 1. Z0 into Z0, that will be Z0 square. So what will be the value of Z0? So Z0 is under root Zin short circuit, under root Zin short circuit into under root Zin open circuit. So what is the scene? Your characteristic impedance is equals to the input impedance. Your characteristic impedance is equals to under root input impedance when your load is short circuit into input impedance when your load is open circuit. So this is your Z0. A lot of time question has been asked on this particular formula. So this I have written for any general transmission line. Now we will derive the same things for lossless transmission line. So what is the formula of ZY, impedance at any particular node on transmission line for lossless transmission line? For lossless transmission line. So for lossless transmission line, gamma is equals to J beta. So what is the formula? Z0 into ZL plus JZ0 tan beta L. I am writing in terms of Y, so it would be tan beta Y, where Y is the distance from load. divided by Z naught into divided by Z naught plus J ZL tan beta Y. And if I need to write down the input impedance, then what will be the input impedance? Input impedance, just Y equals to L I will put, that's it. So Zin is equals to Z naught into ZL plus J Z naught tan beta L divided by Z naught plus J ZL tan beta L. This is your input impedance. Is that clear to you? Okay. Now let's see the special cases. Short circuit load. If your load is short circuited, then what will happen? This ZL will go to 0, this guy will go to 0, this guy will go to 0. Then what will happen? ZL is going to 0, this guy is going to 0, this guy is going to 0. Then Z0 and Z0 is getting cancelled. So what you are left with? J Z0 tan beta L. Are you getting this point? J Z0 tan beta L. Look, what did I do here? ZL is 0. That means ZL is short circuited. So if ZL is 0, what you are left with? This guy is 0 and this guy is 0. Both these guys are 0. Now J Z0 tan beta L and Z0. Z0 get cancelled. What you are left with? J Z0 tan beta L. That's it. Is that clear? So when my output is short circuited, my input impedance is J Z0 tan beta L. Okay. So from here, what you will see? J Z0 tan beta L. Now this I have written in terms of L. I could have written in terms of Y as well. What will be my Z short circuited? What will be my Z short circuited in terms of Y? Basically, I am writing the impedance at any random Y. Z short circuit Y. That would have been J Z0 tan beta Y, right? Just in place of L, it would be beta Y. That's it, right? Now, can you draw the waveform of tan beta Y? Tan function. Basically, what is beta? Beta Y. Beta Y is 2 pi by lambda into Y. So if Y is equals to 0, that means this beta Y is 0. That means tan 0 is 0 only. So your impedance is 0. Basically, if you are here, this is your Y equals to 0 and this is your Y equals to L. So if you are working from here to here, then at Y equals to 0, what do you see? Short circuit. 0 impedance. Yes, the impedance will be 0. Now at lambda by 8, what you will see? 2 pi by lambda, and distance is what I am saying, lambda by 8. So Y value is lambda by 8. So what you are seeing? Pi by 4. So tan pi by 4 is 1. So what impedance you see? JZ0. Is it a inductive impedance or capacitive? Inductive. At lambda by 8 distance, what do you see? Inductive impedance. Right? And you can see the graph as well. Here the value will be positive. The value of tan beta L will be positive. That means this guy will be positive. That means it is an inductive impedance. This is an inductive impedance. At Y equals to lambda by 4, what you will see? What is the value of beta Y? That will be 2 pi by lambda into lambda by 4. That would be pi by 2. So tan pi by 2 is infinity. So what do you see? Infinity. So this kind of graph you see. This is the graph of tan. In elementary classes we have studied it. In mathematics also we have studied it. But the point is, from 0 to lambda by 4 distance, your nature will be inductive. Now after that, what will be your nature? Let's just say this distance was 0 to lambda by 4. This distance was lambda by 4. So from 0 to lambda by 4, your nature is inductive. Is that clear to you? Now let's take another distance. Let's take the distance equals to lambda by 4 we have taken. Lambda by 4 plus lambda by 8 we can take. So 3 lambda by 8. Let's take the distance 3 lambda by 8. 3 lambda by 8 will be somewhere here. 3 lambda by 8. Okay. Lambda by 4 plus lambda by 8. That would be 3 lambda by 8. So at 3 lambda by 8, what do you get? Beta value is 2 pi by lambda into 3 lambda by 8. So what you are getting? 3 pi by 4. So J Z0 tan 3 pi by 4. What that would be equals to? Minus 1. Tan 3 pi by 4 is equals to minus 1. Because tan pi minus pi by 4. Yeah, that would be equals to minus 1. So minus J Z0 you are getting. That means it is capacitive. So from lambda by 4 to lambda by 2, it will show capacitive nature. What do you think what will happen at lambda by 2? What will be the value of beta Y? At lambda by 2, value of beta Y will be 2 pi by lambda into lambda by 2. So that would be pi, and tan pi is 0. So at lambda by 2 your impedance is 0 only. Are you getting this point or not? What we are doing? So first for 0 to lambda by 4 it shows inductive nature, then it shows capacitive nature, then from lambda by 2 to again for lambda by 4 distance, that means from lambda by 2 to 3 lambda by 4 again it will show inductive nature, then 3 lambda by 4 to lambda again it will show capacitive nature. Are you getting this point? Let's erase all these things. Just simple graph we have made. What we have done is that Z short circuit Y we have written, that is J Z naught tan beta Y. Now from here if I keep on walking, so if I walk for 0 to lambda by 4 distance, from 0 till lambda by 4 distance, then inductive nature is shown. Then lambda by 4 to lambda by 2 capacitive nature, then again inductive nature. And what do you see? After every lambda by 2 distance you are getting 0 impedance. That means here you are having 0. Then after lambda by 2 again you will have 0 impedance. Then again after lambda by 2 again you will have 0 impedance. So after every lambda by 2 it is repeating its impedance. Like 0 here, then again at lambda by 2 0, then again at lambda by 2 0 0. So that we will see later on. But as of now, did you understand this point? That what is your input impedance when load is short circuited? Here I should have written Z in input impedance when load is short circuited. Or you can write down Z short circuit Y. So that is J Z naught tan beta Y. And if you are asking input impedance, then that would be J Z naught tan beta L. Now, what kind of questions can be asked? The questions can be asked is that your load is short circuited. Your load is short circuited and the length of your transmission line is lambda by 8. So what kind of nature you will have at input impedance? What will be the nature of input impedance? So that will be inductive for lambda by 8 distance, because from 0 to lambda by 4 it would be inductive only. So if the distance is lambda by 8, it would be inductive. If they say the distance is, if the length is 3 lambda by 8, so what will be the nature? What will be the nature of input impedance? If this distance is 3 lambda by 8, so what will be the nature of input impedance? So you can simply put 2 pi by lambda into 3 lambda by 8. So you don't need to mug it up. In the examination you will put, and then you will get the value of tan this guy. What is this guy? This guy is 3 pi by 4. So you will get the value of tan 3 pi by 4, that is -1. Then you will get to know that the nature is capacitive. So these kind of questions can be asked, that your load is shorted and if you walk some kind of distance, then what kind of nature you will get. So very important concept. So these kind of questions can be asked. Okay. Or they can simply give the length of the transmission line and they can simply ask you the input impedance. So for now you just need to remember this thing, that Z in short circuit is J Z naught tan beta L. That's it. Will you be able to remember this thing? This you need to remember. Then any kind of question they ask, first inductive, then capacitive, inductive, capacitive. This you can derive in the examination as well. But this at least should be in your mind, because this will be again and again used. Now same goes for open circuit load. Now load is open circuited. So what will be your Z in if your load is open circuited? So let's see in this formula. Load is open circuited, that means ZL is equals to infinity. Load is open circuited, that means ZL is equals to infinity. ZL equals to infinity. So if here ZL is equals to infinity, that means this is very high, this is also very high. So this can go to 0 and this can go to 0. So ZL get cancelled. So what you are getting? J Z naught cot beta L. But this J is going upward, so minus sign will be there. So minus J Z naught cot beta L. What we are saying, ZL is infinity. So this guy is very large, this guy is very large. So this guy can be taken to 0, this guy can be taken to 0. Now ZL get cancelled. What you are left with? ZL get cancelled. What you are left with? J, this J goes upward. So minus J Z naught tan beta L goes upward, cot beta L. So minus J Z naught cot beta L. This is your answer. Okay. So your answer is minus J Z naught cot beta L. So this also should be in your mind. So when open circuited, the answer is minus J Z naught cot beta L. Okay. And if I need to write down in terms of Y, basically this was my Z in when load was open circuited. But if I need to write down Z in, or I am writing load is open circuited but impedance at any node at any distance Y. So what that would be? That would be J Z naught cot beta Y minus J Z naught cot beta Y. Same kind of waveform you can draw. You just need to draw the Cohort diagram. You just need to draw the waveform of cot theta. Okay. So initially it will show the capacitive nature, then it will show the inductive nature, then again capacitive nature, then again inductive nature, and this distance will be lambda by 4. This distance will be lambda by 2. This will be 3 lambda by 4. This distance will be lambda. Let's check it out. Okay. So if length is 0, that means this was your y equals to 0, this is your y equals to L. So at length equals to 0, what do you see? Infinity impedance. So if you put y equals to 0 in this equation, what do you get? Minus j z naught cot 0. And what is the value of cot 0? Infinity only. So yes, infinity you are getting. Now let's check at lambda by 8. Where I am checking? At lambda by 8. So minus j z naught cot beta is 2 pi by lambda into lambda by 8. So what you are getting? Cot pi by 4. What is the value of cot pi by 4? 1. That means what you are getting? Minus j z naught. Minus j z naught means if the length is lambda by 8, that means the impedance you are getting minus j z naught. And this is capacitive nature. Yes, capacitive nature. And where will be lambda by 8? Here will be lambda by 8. At lambda by 4 you will get 0 only. At lambda by 4 you will get 0. That's for sure. You can check as well. 2 pi by lambda into lambda by 4. What you are getting? Cot pi by 2. What is the value of cot pi by 2? 0 only. Value of cot pi by 2 is 0 only. So you are getting at lambda by 4 you are getting 0 only. So at lambda by 4 distance you are getting 0. You can check at 3 lambda by 8. Where you can check? At 3 lambda by 8. So let's check at 3 lambda by 8. So which nature you will get? So beta is 2 pi by lambda, y is 3 lambda by 8. So what you are getting? 3 pi by 4. So what is the value of cot 3 pi by 4? That is minus 1. So what you are getting? J z naught. Cot 3 by 4 is minus 1. So what you are getting? J z naught. And J z naught shows inductive nature. So yes, you are having inductive nature at 3 lambda by 8. So at different point you can check, and there in the examination you will be able to tell that what kind of nature you will see depending on your load. If your load is open circuited, then at a distance at 3 lambda by 8 from load, what will be the nature of your transmission line? So you will say inductive nature. How will you say that? Okay, distance from load is 3 lambda by 8. So cot 2 pi by lambda into 3 lambda by 8. Then you will see the value. You are getting j z naught. That means it is inductive nature. So for that you need to remember this formula. Okay, but at least remember this formula. If you remember this formula, then you can derive both of them. But in the examination we are not going to waste time. So in our mind it should be there. Z in open circuited is minus j z naught cot beta L, and Z in short circuit is j z naught tan beta L. How do I remember it? Open O, open circuit O, cot is also having O. So that's why for open circuit cot, and for short circuit tan will come. So for shorter time you can remember it in this manner, but in longer run you will be eventually remembering it, that your open circuit impedance is cot beta L minus j z naught cot beta L, and your short circuit is j z naught tan beta L. Is that clear to you? Okay. And if you multiply both of them, Z open circuit into Z short circuit, then you will get Z naught only. This we have already seen. Basically, if what they will say that your input impedance when your load is short circuited is mentioned, and your input impedance when your load is open circuited, that is also mentioned. What is given? Input impedance when load is open circuited and input impedance when load is short circuited. You need to find the value of characteristics impedance. So what you are going to do? Just multiply both of them and take the under root. That's it. So Z naught is equals to Z open circuit into Z short circuit, and you can verify it here as well. If you multiply both of them, what you are going to get? Minus J into J will be plus 1. Z naught into Z naught will be Z naught square, and tan beta L into cot beta L, that will be 1 only. So what you are getting? Z naught square, right? What we are doing? Z in short circuit into Z in open circuit. So short circuit was J Z naught tan beta L, okay, and open circuit is minus j z naught cot beta L. So if you multiply both of them, j into minus j will be plus 1, z naught into z naught square, tan beta L cot beta L will be 1. So what you are getting is equals to z naught square. So from here this formula we are getting. Okay. Now third condition, matched line. The line is matched. That means ZL is equals to Z naught. ZL is equals to Z naught. That is known as matching. Basically, your impedance is, your load impedance is equals to Z naught only. Your load impedance is equal to characteristic impedance. So what will be your input impedance then? Or any impedance, anywhere you can check the impedance. What that would be? Z naught, ZL is equal to Z naught, J Z naught tan beta Y divided by Z naught as it is plus J ZL is Z naught tan beta Y. So this guy is same, completely getting cancelled. So ZY is equal to Z naught only. So irrespective of the value of Y, it is always Z naught. Basically at all the points, here, here, or at the input, at all the points you will always get Z naught impedance. At all the points you will get Z naught impedance. This condition is known as matched condition. And this is our desired case. Why is that so? Because what is the value of reflection coefficient here? Gamma is equal to ZL minus Z naught upon ZL plus Z naught e to the power minus 2 gamma Y. What is the value of reflection coefficient? ZL is equal to Z naught. So reflection coefficient is 0. That means whatever the power that came here, whatever the power that was given from the source, some power was given. The complete power is transferred to the load. So why we are using transmission line? We are using the transmission line for transferring the power. So from the source, whatever the power that is coming, the complete power is transferred to the load. So that's why this is known as matched condition. And at all the points, your voltage waveform will see Z naught impedance. Here also Z naught, Z naught, Z naught. At all the point, it will see Z naught impedance, and eventually it will transfer all the power to the load. Okay, so we will discuss about it more in this lecture only. Okay, that is the matched condition. So how do we achieve this matched condition? So that we will discuss. But as of now, what you need to remember, that if your load is Z naught, and intrinsic impedance is also Z naught, then irrespective of any condition, always you will see Z naught impedance. Why is that so? Because wave will travel here Z naught, Z naught, Z naught, Z naught, here also Z naught. Always you are seeing Z naught impedance, and there is no reflected wave as well. Okay, yeah. So till now in this discussion of this 20 minutes, what you need to remember? Input impedance for lossless transmission line. For lossless transmission line we are writing, but for any general transmission line also we can write. So first write it down for any general. So what is your short circuit load? So Z in for short circuit, what that was? Z naught tan hyperbolic gamma L, but for lossless it was J Z naught tan beta L for lossless, and this was for any general, or I can say lossy, but this will be asked more. Okay, and what was your open circuit impedance? Open circuit was Z naught cot hyperbolic gamma L, or here it was minus J Z naught cot beta L. Okay, and for matched load, it was always equals to Z naught. Whether it is lossless or lossy or anything, it was always equals to Z naught. So till this point only this discussion you need to remember. Z in when your load is short circuited, that is J Z naught tan beta L, and Z in when your load is open circuited, that is minus J Z naught cot beta L. And if you need to write down in terms of Y, then L will be simply replaced with Y. That's it. Y is that distance from the load. Is that clear to you? Till now the discussion is crystal clear. Very easy discussion, right? Now let's see the input impedance for different lengths. That means this is my some ZL load. It could be anything. The ZL load could be anything. Then what will be your Z in? It could be resistive, it could be capacitive, it could be complex, it could be inductive, it could be anything. But now my length is lambda by 8. This is my length. Okay, the length of my transmission line is lambda by 8. So what will be my input impedance now? So what will be the value of beta L now? Beta L, that would be 2 pi by lambda, and length is lambda by 8. So what you are getting? Pi by 4. So your beta L is pi by 4. So what will be your tan beta L? Tan beta L will be 10 pi by 4, and that would be 1. So what you are getting? Z naught into ZL plus JZ naught divided by Z naught plus JZL. That is your Z in. Okay, don't need to remember it. No need to remember. But one thing is that there. What is that? If I take the magnitude, that is coming out to be Z naught only. Why is that so? Because ZL plus JZ naught, what will be the magnitude of Z in? Magnitude of Z in. So magnitude of Z naught is Z naught only. What is the magnitude of ZL plus JZ naught? That is under root ZL square plus Z naught square. And what is the magnitude of Z0 plus JZL? That is Z0 square plus ZL square. So this and this get cancelled. So magnitude of Zin is equals to Z0. No need to remember, no need to mug up this condition. This condition I don't need to remember. But if in the statement wise, like let's just say they frame a question and they write down which statement is correct. So statement is written for a lambda by 8 transmission line, the magnitude of input impedance is equals to the intrinsic is equals to the characteristic impedance. Then yes, that line is correct. Okay. So you just need to keep in mind that something like that, something for lambda by 8 we have studied. That's it. What you need to keep in mind, that something for lambda by 8 we have studied. What we have studied that you can forget, but something we have studied. So in the examination you will just do this thing, that beta L 10 by 1, then you will write down Z0 into ZL plus JZ0, then you will get to know this is getting cancelled. So amplitude is equals to, magnitude is equals to Z0 only. So for a lambda by 8 transmission line, the input impedance, the magnitude of input impedance is equals to the characteristic impedance. Is that clear to you? Okay, so this you don't need to remember. Now lambda by 4. So what will be my beta L? 2 pi by lambda into lambda by 4. So what you are getting? Pi by 2. Beta L is pi by 2. So what is your tan beta L? Tan beta L is infinity, right? Tan pi by 2, tan beta L is infinity. That means this guy is very large. This guy is very large. Okay, so you can ignore both of them. Basically, this guy has become very large, so you can ignore both of them. You can ignore this, you can ignore this. So what you will be left with? Z0 into ZL can be ignored, Z0 can be ignored. J and J will get cancelled. Z0 upon ZL, tan beta L will get cancelled. Basically, ZL can go to 0, Z0 can go to 0 because this guy is very large. Basically, 2 plus J 1000, something like that you are doing. So 2 you can ignore, no, divided by 5 plus J some 5000. This is something you are doing. So 5 can be ignored, no. So this is what we are doing. And then J and J will get cancelled. Tan beta L will get cancelled. So Z0 by ZL you will be left with. So what you are getting? Zin is equals to Z0 square by ZL. A very important formula for lambda by 4 line. Okay. So what you are getting here, what is the conclusion you can make? Now if your ZL was, let's just say if my ZL was short circuited, then what will be your input impedance for lambda by 4 line? What I am saying, ZL was short circuited, that means ZL was 0. So what will be your input impedance for lambda by 4 line? That would be infinity. So for short circuit load, your input impedance is open circuit. If your ZL was open circuited, then what would have been your Zin for lambda by 4 line? What I am saying, if your ZL was open circuited, that means if ZL was equals to infinity, ZL short circuited means ZL is equals to 0, and ZL open circuited means ZL is equals to infinity. So if ZL is equals to infinity, then Zin would become 0. So for open circuit load in lambda by 4 line, you are getting short circuit input impedance. For open circuit load, you are getting short circuit input impedance. Okay, more condition we can check. Let's check more condition. If your ZL was inductive in nature, then what would have been your Zin for lambda by 4 line? It would have been capacitive in nature. Why is that so? Because this is your Z0 square, whatever it is, divided by J omega L. Then this J would go upward, minus J Z0 square divided by omega L. So what it is making? Minus J. That means it is capacitive. And if ZL was capacitive, then Zin for lambda by 4 would have been inductive, right? So what is happening for lambda by 4 line? In lambda by 4 line, inversion is happening. In lambda by 4 line, inversion is happening. Short circuit, open circuit load, short circuit input impedance, inductive load, then capacitive input impedance, capacitive load, then inductive input impedance. This formula should be in your mind. What is the input impedance for lambda by 4 line? Z0 square by ZL. Directly should be in your mind. Okay, you do not need to derive this thing in the examination. It should be in your mind that what is the input impedance for lambda by 4 line? Z0 square by ZL. Just write it down and you will be able to remember. How you will be able to remember? That after every lambda by 4 there is an inversion. That short circuit open circuit. So by ZL something will come. So Z naught square by ZL. A lot of times it will be used. That's why we are writing it down. Now it is not true only for lambda by 4. It is true for 3 lambda by 4 as well, 5 lambda by 4 as well, 7 lambda by 4 as well. That means it is true for every odd multiple of lambda by 4. Why is that so? Because what you are going to do, beta L, what is beta? 2 pi by lambda into 2n plus 1 lambda by 4. So what you are getting? 2n plus 1 divided by 2. This is your beta L into certainly pi is there. Now if you calculate tan beta L, that will always come infinity. Let's just say if I put n equals to 0, then what I will be getting? Tan pi by 2. That is equals to infinity only. If I put n equals to 1, what I will be getting? Tan 3 pi by 2. That is also equals to infinity. Tan 5 pi by 2, that is also equals to infinity. So for any odd multiple of lambda by 4, if this line is any odd multiple of lambda by 4, odd multiple of lambda by 4, okay? What it can be? Lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, 9 lambda by 4, 11 lambda by 4. So if it is any odd multiple of lambda by 4, then this formula will be applicable, Z naught square by ZL. Is that clear to you? Okay. So for any length is equals to 2n plus 1 lambda by 4. Any odd multiple of lambda by 4. Is that clear to you or not? Okay. So input impedance for any odd multiple of lambda by 4 line is equals to Z naught square by ZL. Always there will be inversion. Do you remember the standing wave pattern when we study in EM wave, right? When we study normal incidence, there we studied about standing wave pattern. So what was happening there? If there is minima, then minima would repeat, this minima would repeat after every lambda by 2. And minima and maxima would be having distance of lambda by 4. So here there was minima, then there was maxima, then here there was maxima, there was minima. So after every lambda by 4, there was inversion, minima, maxima in that manner. And after every lambda by 2, maxima was there. After every lambda by 2, maxima was there. So after every lambda by 2, same thing gets, like after every lambda by 2, you get the same thing. And after every lambda by 4, you get the inversion of that. Is that clear to you or not? So if your length is equals to lambda by 2, then what do you think what will be your input impedance? Try writing it down. Try writing it down on your own. From this slide, what you need to remember, if my length is odd multiple of lambda by 4, then my Zin input impedance is Z naught square by ZL. Now if your length is lambda by 2, then what will be your input impedance? Try writing it down. So what will be your beta L value? That would be 2 pi by lambda into lambda by 2. So beta L will be equals to pi only. So what will be your tan beta L? What is the value of tan pi? 0 only, right? So that will be 0. So this will be 0. This will also be 0. So what you are getting? Z naught into, this guy will go to 0. This guy will go to 0. ZL by Z naught. Then Z naught get cancelled. So what is the Zin you are getting for lambda by 2 line? That is equals to Z naught. Sorry, not Z naught, sorry. That is equals to ZL. Because Z naught is getting cancelled. So what is happening? What do you see? What is happening here? This ZL is again appearing at the input impedance after every lambda by 2 line. But this is not true only for lambda by 2. This is true for any multiple of lambda by 2. What I mean to say is that if my length was lambda, any multiple of lambda by 2, I am saying length can be any multiple of lambda by 2, where n can be varying from 0, 1 to anything. 0, 1 to anything. That means let's just say n was 2. N was 2, then length would have been lambda. Then what will be the value of beta L? Beta L would have been 2 pi by lambda into lambda. That would be 2 pi. So what will be the value of tan beta L? That would be tan 2 pi. And tan 2 pi is equals to tan 0. That would be equals to 0 only. So again, same formula you will be getting. So this is true for every n lambda by 2. Again, you need to remember this thing as well. We will certainly write down all the conclusion. Do not worry about that. But here we are building up the results. What results we have built up? For any odd multiple of lambda by 4, inversion will be there. Formula will be Z naught square by ZL. For any multiple of lambda by 2, same impedance will occur. ZL will same occur. Is that clear to you? If this length was lambda, then what will be the input impedance? ZL. If this length was 3 lambda by 4, then what will be the input impedance? Z0 square by ZL. If this length was 3 lambda, then what would be the input impedance? Because this is multiple of lambda by 2 only. 3 lambda is the multiple of lambda by 2 only. So what will be the input impedance? ZL only. But if the length was lambda by 8, then you need to calculate. If the length was lambda by 6, then you need to calculate. What we are studying? We are studying for odd multiple of lambda by 4 and any multiple of lambda by 2. These two cases only we remember. Is that clear to you? Right? So certainly we are going to write down everything that we need to remember in one page only. But as of now, these results we have got. That after every lambda by 2, same impedance will occur, and after every lambda by 4, like odd multiple of lambda by 4, inversion will occur. Z0 square by ZL. Is that clear to you? Okay. What is the conclusion? If length is odd multiple of lambda by 4, that means 2n plus 1 lambda by 4, then Zin is equals to Z0 square by ZL. Need to keep in mind. Okay. And if it is any multiple of lambda by 2, what I can say? Multiple of lambda by 2. Simply multiple of lambda by 2. Then Zin is equals to same whatever that is there at the load. Is that clear to you? Okay. So this is the conclusion. That's it. And what else we need to remember? Your Zin open circuited is minus j Z0 cot beta L, and your Zin short circuited is j Z0 tan beta L. If you remember only these things, you will be able to solve all the problems of input impedance. Okay. Now solving problem is also important, so do not ignore the problems. I will pause the video and now we will start solving the questions. Okay. So let me take a break. You can also take a break. You can just revise it up. I don't think there is anything to revise, just simple things you need to keep in mind, and then we can start solving the problems. Okay. So I will take a pause. You can also take a pause. Yeah, so let's start solving the problem. So characteristics impedance of a transmission line is 50 ohm. The input impedance of the open circuit load, the input impedance of open circuited line, or you can say open circuited load, is given as this. You need to find the when the transmission line is short circuited, then what will be the value of input impedance? What is the input impedance given when line is open circuited? That is given as 100 plus J150. And what formula we have studied for open circuited? J Z0 cot beta L. That is for lossless transmission line. So what we assume that whether it will be inductive or it will be capacitive, right? Here we have seen whether it will be inductive or capacitive when line is open circuited. But here what is this? This is complex. That means certainly this is not lossless line. This has to be lossy line. Are you getting this point? Zin open circuited is not inductive or capacitive. It is complex. That means certainly it is a lossy line. And for lossy line, what is the formula? For the lossy line, the formula is Z0 cot hyperbolic open circuit is there. So cot hyperbolic gamma L. Now you said that, sir, they will never ask for hyperbolic function. Now they are asking for hyperbolic function. But you do not need to do this calculation, because what you need to find when line is short circuited, then what is the value of input impedance? So what you need to find? I need to find this value, Z0 tan hyperbolic gamma L, right? So from here, can I get the value of tan hyperbolic gamma L? Yes. What this is equals to? This is equals to 100 plus J150. And what is the value of Z0? Z0 is 50 ohm. The Z0 value is 50 ohm. So Z0 value is 50 ohm. So 2 plus 3J is equals to cot hyperbolic gamma L. What we are doing is that 100 plus J150 divided by Z0. What is Z0? Z0 is 50 only. Is equals to cot hyperbolic gamma L. So what is your cot hyperbolic gamma L now? That is equals to 2 plus 3J. So cot hyperbolic gamma L is 2 plus 3J. So what will be your tan hyperbolic gamma L? 1 by 2 plus 3J. Just negative reciprocal of that. So what is the value of Z0? Z0 is 50. So what did I tell you? That you will never have to do hyperbolic calculation. Again, here also you don't have to do hyperbolic calculation. So this is what you are getting, Z in short circuit. That is 50 upon 2 plus 3J. Now can I solve it? Yes. What I will do? Multiply and divide with 2 minus 3J. So which answer I am going to get? At downward it will become 4 plus 9, 13. So it would be 50 by 13, whatever I am going to get. Here there will be negative sign, so only one option is there where there is negative sign. So this is what we are getting. Okay. So you can solve this, a very simple calculation. You are going to get 7.69 minus J 11.54 ohm. So the thing is, again here as well, I don't need to do the hyperbolic calculation. So just be smart enough in the examination. Z in open circuited was given, that means certainly it was lossy. So I have to use this formula. From here I got the value of quote hyperbolic gamma L, and then I need tan hyperbolic gamma L, so just the negative reciprocal. Just reciprocal I need to take, that's it. Okay. Let's see this question. Over transmission line is having characteristic impedance of R node. What is the input impedance Z in equals to? From here I need to see the impedance. So what all I can see, there is this transmission line between node A and B. This I call as node A, this I call as B. So between node A and B, one transmission line, this line is connected, and another transmission line, this line is connected. The length of this transmission line is lambda by 2. That means 2 R naught will be copied as it is between A and B. Are you getting this point? What I am asking is that what will be this ZIN1 and what will be this ZIN2? So for lambda by 2 line, I know that my ZIN2, ZIN1 will be equals to the load impedance, that is 2 R naught. What will be my ZIN2? That is for lambda by 4 line. What is that? Z naught square by ZL. What is the formula? Z naught square by ZL. So R naught square divided by ZL. What is ZL? R naught by 2. So that would be 2 R naught only. So between A and B you are having ZIN1. Between A and B you are having ZIN2 as well. So that means both are in parallel. Between A and B you are having some resistance R. Between A and B you are having some resistance R. That means both are in parallel. Same goes here. So this is your lambda by 8 transmission line. Lambda by 8 transmission line. Lambda by 8 transmission line. From here I need to find Zin. At the load what I am having, this node I am calling A, this node I am calling B. So A, B. Okay. Between A, B I am having 2 R naught parallel with 2 R naught. What I am having? 2 R naught parallel with 2 R naught, which is equals to R naught only. And what is the impedance of this line? That is R naught. So this line is lambda by 8 line. So what is the formula for lambda by 8? So Zin would be equals to Z naught into ZL plus JZ naught tan beta L. But what will be the value of beta L? Beta L will be 2 pi by lambda into lambda by 8. So that would be pi by 4. So tan beta L will be 1 only. So this will be 1. So 1 I can ignore. Divided by Z naught plus JZL. Right? Now what is your Z naught? Z naught is R naught. What is your ZL? ZL is also R naught plus J R naught divided by R naught plus J R naught. So what is the answer you are getting? Zin is equals to R naught only. So that's it. This is the answer. So what answer you are getting? Zin is equals to R naught. This is the answer. Okay. What did we do? Between A and B we saw this equivalent. Then we saw this equivalent. Both coming into parallel is becoming R naught only. Then what is the formula of Zin? For lambda by 8 line, you can derive it directly. So Zin is equals to Z naught. This is separate thing. Okay. This is separate thing. So Zin is equals to Z naught into ZL plus JZ naught divided by Z naught plus JZL. So from there you got the answer equals to R naught. So this is the answer. Very straightforward question. Let's see the next one. Here what is happening? Here you need to find admittance. Here you do not need to find impedance. Here you need to find admittance. What is admittance? Simply the negative of impedance, right? 1 by Z. So that I need to find. So how will I find? Here I can see two transmission line. This is one transmission. Yeah, this is one transmission line. Then this is one transmission line. Basically, this node is A. This node is B. So from between A and B, there is this one transmission line and another transmission line. So for lambda by 2 line, what will be the impedance? Simply it will be copied, same 100 ohm will be copied. So at AB, if I make two nodes A and B. So because of this transmission line, I am calling this a transmission line 1. This as transmission line 1 and this as transmission line 2. So for transmission line 1, my Z in 1 would be 100 ohm only, because the line is lambda by 2, right? Line is lambda by 2, so same will be copied. So that would be 100 ohm only. Now for other transmission line, this is shorted. This line is shorted. So what will be the input impedance? What will be your Z for transmission line 2? What will be your Z in 2? Do you remember the formula for short circuit? For short circuit it would be tan. For open circuit it is quote. For short circuit it would be tan. And certainly it is lossless. It should be given in the question. Okay. So J Z naught tan beta L. So beta is 2 pi by lambda, and what is the value of L? L is lambda by 8. So what it will be? Tan pi by 4, that would be 1. So J Z naught you are getting. J Z naught. What is the value of Z naught? Z naught is 50. So J50, this is the other impedance you are getting. So here you are getting other impedance, that is J50. Between A and B only. Between A and B you are getting this impedance, that is J50, and between A and B only you are getting this impedance which is 100. So J50. Now from here I need to find admittance. Can you write down the 1 by Z value? Can you write down the impedance? That would be equals to, this is a separate thing. This is a separate thing. So your 1 by Z is equals to what? 1 by Z is equals to 1 by J50 plus 1 by 100, right? And what is 1 by J? 1 by J is Y only. So what is 1 by J50? That would be minus J 0.02 plus 0.01. That's it. This is the answer. And unit will be Maho. What will be unit? Maho. So minus J 0.02 plus 0.01 Maho. Are you able to understand what we are doing? Simply we just need to solve the transmission line. That's it. Very easy. Like these questions are very, very easy. Every single guy who has studied this subject in a good manner, he will be able to solve. Just between A and B you need to find the equivalent of this and then equivalent of this. That's it. Okay. So this is the answer. Let's see the next one. So here short circuit load is given. You need to find Z in. Z naught value is given 120 pi ohm. This is air field. In between there is air. It is excited by a source. Here there will be a source. Okay. Here there is a source which is having a frequency of 37.5 megahertz. 37.5 megahertz. The length of this transmission line is 3 meter. Okay. You need to find the input impedance. So what will be your input impedance? Zin is equals to short circuit. For short circuit, what is the answer? JZ naught tan beta L. Right? For short circuit, the answer is JZ naught tan beta L. Right? Now, nature of input impedance you need to tell. You don't need to tell the exact value. Nature you need to tell, whether it will be capacitive, inductive, or you can tell the exact value as well. Now you need the value of beta. So beta is 2 pi by lambda, right? I know beta is 2 pi by lambda. So what I'm going to do, I'm going to calculate the length in terms of lambda. Why is that so? Because if my length is in terms of lambda, then I know standard results, right? If my length is in terms of lambda, then I know standard results. So always my target would be to find the length in terms of lambda. So first target is to find the lambda value. So this is the formula I need to apply. Now I need to find lambda value. So how will I find lambda value? What is my lambda? Lambda will be Vp by f. Vp by f. Since it is air, so what will be my Vp? 3 into 10 to the power 8 divided by f. What is my f? F is 0.375 into 10 to the power 8. This is 37.5 megahertz. So 37.5 10 to the power 6 or 0.375 into 10 to the power 8. So what is the value of lambda you are getting? 3 upon 0.375. 3 upon 0.375. So 8 value you are getting. 8 meter. So basically 8 meter is equals to lambda. 8 meter is equals to lambda. So 1 meter is equals to lambda by 8. So 3 meter is equals to 3 lambda by 8. This is not in my standard results. This is not into my standard results. So I have to calculate now. Right? So JZ naught tan beta L 2 pi by lambda into 3 lambda by 8. So what I am getting? 3 pi by 4. J Z naught tan 3 pi by 4. And what is the value of tan 3 pi by 4? That is -1. You can calculate from your calculator as well. Like you will be having the scientific calculator, from there also you can calculate, or directly you can say tan 3 pi by 4. What will be your tan 3 pi by 4? That would be tan pi minus pi by 4. And tan pi minus pi by 4, that means second quadrant. Second quadrant, tan would be negative. So minus tan pi by 4. And what is the value of tan pi by 4? That is 1 only. So -1. So what you are getting? Minus j z naught. And z naught value 125 you already know. So which kind of behavior is that? Capacitive. So this is the answer. Okay, very easy question. Like very easy question. Just you need to write down the things. Always try to write down the length in terms of lambda, because in terms of lambda we know the standard results, and then you will be able to get the final answer. Is that clear to you? So in that manner only we need to solve problem. So try solving this question on your own. Let me explain the question. There is this one transmission line 1. Okay, there is this transmission line yellow one, that is transmission line 2. Then there is this transmission line 3, and then there is this transmission line 4. Four transmission lines are there connected in this manner. In between, at 13.5 centimeter from the source, there is another transmission line connected. It has a length 3 centimeter. This is 13.5, this is 27. This is 3 by 4 centimeter, this is 1 by 4 centimeter. What is the medium? Here the medium is mu r equals to 1, epsilon r equals to 4. Here the medium is mu r equals to 3, epsilon r equals to 3. So this is the medium. Is that clear to you? Here the medium is air. In this transmission line as well, there is the medium, that is air only. This transmission line is open circuited. This transmission line is 10 ohm and 50 ohm. This is the load. Now what you need to find? You need to find this Z in value. And Z naught for all the transmission line is 50 ohm. So this is the question. I hope you must have understood the question. So how we need to start? We need to come here. So from here we need to start. If this I call as node A and B. So between A and B there is this transmission line 3, and between A and B there is transmission line 4 as well. But I don't know the length in terms of lambda. So this will be my first target, to get the length in terms of lambda. So for that I need the value of lambda first. So what will be my lambda? So first let's solve for transmission line 3. Transmission line 3. Okay. What will be the value of lambda? Lambda will be Vp by F. F is given. Yes, it is excited with 50 megahertz. Okay. F is given, that is 50 megahertz. That is 5 into 10 to the power 7 hertz. What will be Vp? Vp will be, what is the formula of Vp? Do you remember? Omega, Vp is equals to omega by beta. So that is 1 upon under root mu epsilon, right? Or you can write down C upon under root mu r epsilon r. So what will be Vp? 3 into 10 to the power 8 divided by under root mu r epsilon r. 4 into 1 under root 4 divided by F. F is 5 into 10 to the power 7. So what you are getting? 3. Lambda is 3 meter. So this is your lambda. Here length is given as 3 by 4. That means length is equals to lambda by 4, right? This is your length. So what will be your Z in 1 or Z in 3? I'm gonna write. So what will be your Z in 3 for lambda by 4 length? What is the formula? Z naught square by ZL. So Z naught square by ZL. ZL is 10 ohm. Z naught square by ZL. What is Z naught square? Z naught square is 50. So 50 into 50 divided by 10. That is 250 ohm. So this Z in 3 is 250 ohm. What about this guy now? For this guy as well, I will do the same thing. I will find the value of lambda. So now from here I will get 250 ohm, that I have calculated. Now next task is to solve the transmission line 4. Just solve the problem. In that same manner you just proceed. It will be very easy for you. Okay, just solve this one now. So what will be my lambda now? Lambda will be again the same formula, Vp by F. Vp will be 3 into 10 to the power 8 divided by under root mu r epsilon r. What that would be? 3 into 3, that would be 9. And divided by F. F is 5 into 10 to the power 7. So what you are getting? 2 meter. Length you are getting, lambda you are getting 2 meter. Again let me check. This was 2, this is 3. Okay, so 1.5 times of that, that would be 2 meter only. Yeah, so 2 meter we are getting. Lambda is 2 meter we are getting. So what is the length here? 1 by 4. So what is the length now? Length is lambda by 8. 2 by 8, that is 1 by 4 only. So length is lambda by 8 centimeter. So what will be the value of Z in now? Z in will be equals to Z naught into ZL plus Z in 4, I am calling it. Okay, Z in 4. So ZL plus J Z naught upon Z naught plus J ZL. Here I can see that Z naught and ZL are same. Basically, here Z naught is 50 ohm. So what you are getting? 50 plus J50 divided by 50 plus J50. So this will be getting cancelled. So Z in 4 is coming out to be 50 only. Basically, you put 50 here. ZL is also 50 plus J50 divided by 50 plus J50. So this guy will get cancelled. So only 50 ohm you are getting. So Z in 4 you are getting 50 ohm. So from one end you are getting 50 ohm, and from here Z in 3 you are getting 250 ohm. Okay. So now your between A and B, what I can do now, I can copy this much transmission line. This much transmission line I can copy and add the load. What I can connect? Add the load of it. I need to find Z in only and add the load between A and B. I can connect two impedances. Which are those impedances? 50 ohm parallel with 250 ohm. 50 ohm parallel with 250 ohm. What is the value you will get? 250 into 50 divided by 300. सही तो कर रहा हूँ क्या मैं? 50 आएगा ना? 50 250. Okay. So 50 into 250 divided by 300. So 41.67 you are getting. 41.67 ohm. So this much is sold. Now at this node there are two transmission line, this transmission line and this transmission line. So now at this node I need to find. So let's call these port as CD port. So along CD port I need to find the equivalent now. Okay, is that clear to you? Now for both of the transmission line there is air in between. So what will be the lambda? Lambda will be C by F. So 3 into 10 to the power 8 divided by F. F is, what is your F? 5 into 10 to the power 7. So 30 by 5, 6 centimeter. 6 centimeter. So this length is lambda by 2, right? What is this length? Basically, lambda is equals to 6 centimeter, or I can say 6 centimeter is equals to lambda. 6 centimeter is equals to lambda. So what will be 27 centimeter? So 1 centimeter is equals to lambda by 6. 1 centimeter is equals to lambda by 6. So 27 centimeter will be equals to lambda by 6 into 27. So what you are getting? 9 lambda by 2. If you solve it, what you are getting? 9 lambda by 2. So this is the multiple of lambda by 2. Are you getting this point? This length is 9 lambda by 2. So any multiple of lambda by 2 and this length is lambda by 2. So what will be the equivalent across CD you will get? What do you think? This is lambda by 2. So again same thing will be copied, but that means open circuited. If I say what will be your Z in 2? What will be your Z in 2? So Z in 2 will be infinity only, because length is lambda by 2. And this is your transmission line 1 and this I am calling as transmission line 1 dash. Transmission line 1 dash I am calling. So what will be your Z in 1 dash? That is also a multiple of lambda by 2. That is also a multiple of lambda by 2. That means same thing will be copied. That would be 41.67 ohm. Why is that so? Why is that so? Because your length is multiple of lambda by 2. So Z in 1 dash is 41.67 ohm. Z in 2 is infinity. Now at CD node, infinity parallel with 41.67 ohm. So what is the answer you will get? Infinity parallel with 41.67 ohm. That will be 41.67 ohm only. So now your transmission line has reduced to this much. What this has reduced to? So what we need to do is that just need to remove it off. Now this is how it is reduced. And here at CD, what you are having? 41.67. 41.67 parallel with infinity. That would be 41.67 ohm. Now this length is 13.5 centimeter. So for this as well, lambda is same. So 6 centimeter is equals to 6 centimeter is equals to lambda. That means 1 centimeter is equals to lambda by 6. So 13.5 centimeter is equals to lambda by 6 into 13.5. If I do the calculation, what do I get? 2.25 lambda. Okay, and that can be written as 10 by 4. 10 lambda by 4. Is that so? Lambda by 6 into 13.5. 13.5 divided by 6, 2.25 only. 5 divided by 6, 2.25 only. 2.25, 10 by 4 is equals to 2.25 only. No, 2.25. 9 by 4. So this is your 9 lambda by 4. What did I do? I got to know that it is 2.25. 2.25 lambda. From here I got to know that it is 2.25 lambda. So it can be written as 9 lambda by 4. Because 10 by 4 is 2.5. So I thought that it would be 9 lambda by 4. So this is odd multiple of lambda by 4. And if anything is odd multiple of lambda by 4, then what will be your Zin? Zin will be equals to Z0 square by ZL. Why is that so? Because length is odd multiple of lambda by 4. Right? So Z0 square by ZL. What is the value of Z0? Z0 is 50 only. So 50 square divided by 41.67. So what answer we are getting? 50 into 50 divided by 41.67. So 60 ohm we are getting. So the answer is 60 ohm. So these kind of questions are expected in your examination. Till now they did not give the length, or they did not connected this much of circuitry. But if they connect any circuitry, if they ask you the value of VP, then they ask you to convert into lambda, then you write down the length and then you can write down input impedance. So just you need to have the patience. Certainly you will get the answer. We did nothing. We just started from the load. My target is to make the load here. So here at this node, I know that there are two transmission lines, and here also I know there are two transmission lines. Both are in parallel between A and B, both are in parallel. I just converted this length 3 by 4 and 1 by 4 in terms of lambda. Then I got to know this length was lambda by 4 and this was lambda by 8. So for lambda by 8, I need to apply the formula. For lambda by 4, I directly remember the formula. So 250 and 50, both are coming into parallel. So this is replaced with 41.67. Then this part of line is there and this part of line is there. So what did I get to know from there? That this length is 27 centimeter. First I got the value of lambda. So this is multiple of lambda by 2. If that is multiple of lambda by 2, then directly it will be copied, and this is also lambda by 2 only. So directly it will be copied. So 41.67 parallel with infinity, that will be 41.67 only. Now circuit is reduced like this. Now this is 13.5. This 13.5 is the odd multiple of lambda by 4. So from there I go to know that it will be Z0 square by ZL. So 60 ohm is the correct answer. Is that clear to you? Okay, so in that manner, if you have the patience, you will be able to solve these kind of problems very easily. Let's go to the next concept, that is your impedance matching. Now what do I mean by impedance matching? Your load impedance should be matched with Z0. And why do you require that? Because at that point your reflection coefficient will be 0. This we have already seen. So what is the formula of your reflection coefficient? ZL minus Z0 upon ZL plus Z0 e to the power minus 2 gamma y. When ZL is equals to Z0, no reflection. If there is no reflection, that means complete power is transferred power transferred to the load. Okay, well and good. So ZL is equals to Z naught. This is our target. Our target is to match the load to Z naught. So now what we are going to do? We are not going to do anything with this transmission line. Okay. Now what I am going to do is that I am going to break this load, and in between I am going to introduce another transmission line, and that transmission line will have the length of lambda by 4 or odd multiple of lambda by 4. What did I do? I did not do anything with this Z naught. What did I do is that I introduced another transmission line which is having a length of odd multiple of lambda by 4. Is that clear to you? And then I connected the load. Now what is my target? Whatever the power that is coming here, the complete should be transmitted to this side. That's it. This is my target. How much is given to ZL? That is not my target. My target is whatever that is coming here, there should be no reflection. That means whatever the impedance you see here, that should be equal to Z naught. Is that clear to you? Basically, equivalent of this much should be equal to Z naught. This is a way. This is what we do. This line is known as quarter wave transformer. What it is known as? Quarter wave transformer. So in between we introduce QWT. The introducing QWT, what is the target? The target is to make Z naught equals to Z in. So let's just say this transmission line has an characteristics impedance of Z naught dash. Then what will be the impedance here? What do you think? What is my target? That my Z in should be equals to Z naught. What will be the value of Z in? That would be, if the length is odd multiple of lambda by 4, then it would be Z naught dash square by ZL. So what will be the value of Z naught dash? That would be Z naught into ZL. So for the purpose of impedance matching, you introduce a quarter wave transformer of characteristic impedance Z naught dash. So what will be the value of that Z naught dash? That is equals to under root Z naught into ZL. That's it. These kind of questions are directly asked. This is known as impedance matching. This was your condition. You need to deliver the complete power from this transmission line. Basically, here there should be no reflection. So what did you do? You introduce a quarter wave transformer. Length is 2n plus 1 lambda by 4, and then you connected the load. Then your target is to match this impedance to Z naught. What is this impedance? That impedance is Z naught dash square by ZL. That should be equal to Z naught. From there, Z naught dash value is under root Z naught ZL. This kind of questions can come in your examination as well. So load impedance of 200 ohm is to be matched with 50 ohm lossless transmission line. Are you able to understand? 50 ohm lossless transmission line. 50 ohm lossless transmission line is there, and this should be matched to 200 ohm load. 200 ohm load and 50 ohm transmission line. So what should be the characteristics impedance of QWT using quarter wave line transformer? So what should be the characteristic impedance? So that characteristic impedance would be under root 200 into 50. So directly you will remember it. Okay. You do not need to derive it there, that you will introduce a quarter wave transformer here, then you derive it. No. So what is the answer you are getting? 100 ohm. Okay. So the answer you are getting is 100 ohm. So this is the first portion of this question. Now in the second portion, what they are saying, if matching is done both at 429 megahertz and 1 gigahertz, then the length of transmission line can be. What can be the length? The length can be 2n plus 1 lambda by 4. I know this thing. And it could be 2n plus 1 lambda by 4. That means it could be lambda by 4 or 3 lambda by 4 or 5 lambda by 4 or 7 lambda by 4 and so on. Odd multiple of lambda by 4. Now, what is the values of lambda with respect to that? Basically, if the source is of the applied source here, the applied source can be of 429 megahertz as well, and it could be of 1 gigahertz as well. So for both of the condition, both guys should be happy. Basically, if you use 429 megahertz source, then also matching should be done. And if you use 1 gigahertz source, then also matching should be done. So with respect to this guy, what will be the value of lambda? And with respect to this guy, what will be the value of lambda? So lambda is equals to C by F. I will assume air only, lossless transmission line. So I will assume velocity equals to C. Okay. So 3 into 10 to the power 8 divided by 429 megahertz. Mega. Okay. So what you are getting? 3 upon 4.29. 429 megahertz. So we are getting 0.699 meter. Or I can write 69.9 centimeter or 0.699 meter. Since all the options are in meter only, so let it give meter. So this is your lambda. Okay. And what is your lambda 2? And if I do divide by 4, so here lambda 1 by 4 value is coming out to be 0.174. This value is coming out to be there. Okay. Meter. And if I found lambda by 2, that is C by F only. So 3 into 10 to the power 8, 1 giga. So that is 0.3 meter. Okay. So lambda by 4 would come out to be 0.3 divided by 4. That is 0.075. 0.075 meter. Now this guy is saying that 0.075 meter it should be, and this guy is saying that 0.0174 it should be. But is this the only possible way that you need to put only 0.174? No, you can put 0.174. You can put 3 into 0.174. You can put 5 into 0.174. Odd multiple of lambda by 4. So 1, 3, 5. You can put 7 into 0.174. Similarly, here you can put 0.075 or 3 into 0.075 or 5 into 0.075 or 7 into 0.075, or it can go ahead as well. So the line which is common for both of them, that we will pick. Are you able to understand? The line which is common for this guy as well and which is common for this guy as well. Basically, we need to satisfy this lambda 1 by 4 as well and lambda 2 by 4 as well. So this guy is saying this 429 megahertz is saying that you can have these lengths, and 1 gigahertz is saying that you can have these lengths. So the length which is common to both of them, that will be our answer, no? Right? So in this manner we cannot keep on calculating. What we will do, we will take help of options. So 82.5 centimeter divided by 82.5 centimeter means 0.825 centimeter. Sorry, 82.5 centimeter. Options. What I am doing, I am going with the options. In the options, option A is saying 82.5 centimeter. So that is 0.825 meter. So first I will see that whether this guy is happy with this length or not. Basically what I am gonna do, 0.825 divided by 0.174. What I am getting? Divided by 0.174. What I am getting? 4.74. That means this length is 4.74 times of lambda 1 by 4. That means this answer cannot be correct. You need odd multiple. What you need? Odd multiple is required. Odd multiple required. Odd multiple of lambda 1 by 4 is required. But that is you are not getting here. So this option is gone. Let's see the second one. 1.05. 1.05 meter. Okay. So what I'm gonna do, 1.05 divided by 0.174. I need to check for this guy as well. I need to check for 0.075 as well. But if 0.174 is not even satisfying, then why we should check for 0.075? Are you getting this point? So now I am checking for 0.174. So 1.05 divided by 0.174. What I am getting? 6. What I am getting? 6. So this is your 6 of lambda 1 by 4. This is also not applicable. Why is that so? Because you require odd multiple. This is your even multiple. So this is also not applicable. Third option we go. 1.58 meter. 1.58 meter. So what I'm gonna do? 1.58 divided by 0.174. 1.58 divided by 0.174. So what I'm getting? 9. So that means this is 9 lambda 1 by 4. So this guy is happy. Basically, this is your odd multiple of lambda 1 by 4. So this length is happy for lambda 1 by 4. But I need to check for lambda 2 as well. So for lambda 2, what I'm gonna do? 1.58 divided by 0.075. What I'm getting? 1.58 divided by 0.075. So you are getting 21. So that means this is 21 times of lambda 2 by 4. So this is also odd multiple and this is also odd multiple. That means this length can be your possible option. So C is the correct answer. You can check in the same manner for D as well. What we are doing is that we get to know that my length should be lambda by 4. But there are two frequencies. So this length and this length. Two kind of length would be there. But they can have the multiple. They can have 3, 5, 7 in that manner. Now wherever you get the matching, that means what will happen is that if you multiply this by 9 and this by 21, then the length would come out to be 1.58 meter. The length would be same for both of them. So at 1.58 meter, they will say that we both are happy. Basically, if you put 0.174 length, then he will say that I am not happy. If you put this, then he will say that, then this 1 gigahertz will say that I am not happy. If you put this, then 429 megahertz will say that I am not happy. If you put this, then 1 gigahertz will say that I am not happy. But if you put 0.174 into 9, then lambda 1 by 4 is also happy. And if you put 0.075 into 21, then this 1 gigahertz is also happy. So both are happy. So that you need to find that where both will be happy. So for that, what did we do? We started picking the option. In the first one, I got to know that this is not even odd multiple of lambda by 4. In the second option, I got to know that it is even multiple of lambda by 4. Then that is also not applicable. Here I got to know that yes, it is odd multiple. This is also odd multiple. Both are odd multiple. That means both will be satisfied with this option. So 1.58 meter, that is the correct answer. Is that clear to you? So yeah, this is your impedance matching. A very easy concept. Simply they will ask you Z0 dash value and then they can ask you this concept as well. Which concept? This concept that for if your circuit can run at two frequencies at 429 megahertz and 1 gigahertz, if your circuit is running at two frequencies, then what length you will be satisfied with. So you always need to remember the length would be odd multiple of lambda by 4. Is that clear to you? Yes. There is another way of matching, that is stub matching. So in stub matching, what do you do? What do you mean by stub? So let's just say this is a transmission line. This is my transmission line. So, and this is your load. Here you are having some load. This is my load. So now at some distance from load, let's just say this distance is some LS. So at some distance from load, I connect another transmission line. Now I either keep this line as shorted or open. At some distance, at LS distance from load, I connect another transmission line. I keep it either short or open. Okay, and the length of this transmission line could be anything. This length, this I am calling as DS. This DS could be anything, this LS could be anything. What I am doing, there is this transmission line which has some load. So some distance from load, some LS distance from load, I connect another transmission line which has any Z0. Okay, it can have any Z0. I will either keep it shorted or open circuited, and this length can also be anything. Then my target would be this I am calling as A, this I am calling as B. So impedance at AB should be equal to Z0. This would be my target. What I need to do? I need to do impedance matching. I got to know that my ZL is not equal to Z0. My ZL is not equal. This transmission line is having Z0 impedance. So I got to know that here ZL is not equal to Z0. So that means impedance matching is not there. So now to do the impedance matching, what I am doing? From the load at some LS distance, I am introducing as stub. This is known as stub. This could be either open circuited or short circuited. Okay, this could be either open circuited or short circuited. Now at AB, I will find the equivalent impedance. What will be the equivalent impedance? So at AB, equivalent impedance will be coming because of this stub. That would be J Z naught 10, since it is short circuit, so J Z naught 10 beta. And another impedance would be coming because of this, right? Have we calculated this kind of question? Yes. One was coming because of this and another was coming because of this. So whatever the impedance that you get here, which impedance we got here, that is 41.67. So that I need to make equals to Z naught. This is my target. So accordingly, I will decide this length. Accordingly, I will decide this LS length. Accordingly, I will decide this DS length as well. And once I have decided this length, then I will connect this stub and I will be able to do my impedance matching. Is that clear to you? What is the process? No one will ask you this process in the examination. I am just telling that what is the reference of this question. This question was asked in GATE examination. What is the reference of this question? You are doing impedance matching. So Z naught is not equal to ZL. So my target would be that whatever the ZAB I get, that should be equal to Z naught. So whatever the power that is coming here, the complete will be transferred here. That's it. What power will be transferred to ZL, that I don't know. But certainly whatever the power that was coming here, complete will be transferred to AB at least. That I know. Okay. So for that I introduce a stub at LS distance from load. So ZAB I will get, that will come out to be because of the stub and because of this much length of transmission line. And the impedance whatever that I get, that I will make equals to Z naught. So accordingly I need to decide the length LS and DS. Is that clear to you? Okay, and that you do with the help of Smith chart, which is not in your syllabus. Smith chart is in your syllabus, but this stub matching is not in your syllabus. This is a vast topic which you are going to study when you do masters in RF domain. If you do the masters, then certainly you are going to study this stub matching using Smith chart. I will try to give you the hint that how you can do it when we study Smith chart, but this is not in your syllabus. In the GATE examination, they will never ask you the value of LS and DS. Now, some people would be having the doubt that, sir, how we will calculate this LS and DS? So that you can calculate with the help of Smith chart. So in GATE examination, no one will ask you, but once you do the masters, there you will be doing it. Okay. In the GATE examination, this kind of question was asked. What they are saying? The impedance matching network shown in the figure is to match a lossless line having characteristic impedance Z naught equals to 50 ohm with load impedance ZL. So this Z naught should be matched with this ZL. This is what they are saying. A quarter wave line having a characteristic impedance Z1 equals to 75 ohm. So this is a quarter wave line is used here. Okay, is connected to ZL. Two stubs. This is your one stub. Short circuit stub is there. Another one is open circuit stub. Two stubs are used. Each of characteristic impedance 75 ohm are connected to the quarter wave line. One is open circuited, one is short circuited, one is having length at 0.25, whatever it is. So what this I can already see, one is shorted, one is open. The length is 0.5 lambda and another length is 0.25 lambda. The impedance matching is achieved when real part of ZL is equal to what? Okay. So my target is to find ZPQ. What is my target? My target is to find ZPQ. So let me show it here. First I will find ZPQ, and then what I'm gonna do, I'm gonna just put this ZPQ equals to Z naught. So this is the target of this question. You just need to know the meaning of impedance matching. That is, whatever the impedance you see on this side, whatever the impedance you see on this side, that should be equals to Z naught. So ZPQ should be equals to Z naught. Okay. Now this is your open circuit load. What will be the equivalent ZRS? What will be ZRS? At ZRS you are having ZL. In parallel to that, you are having infinity impedance. Why is that so? Because length is 0.5 lambda. This length is lambda by 2, and in lambda by 2 open circuit will be copied here. So because of this transmission line, the impedance you are getting is infinity only. So ZRS is equal to ZL only. Is that clear to you? Okay. Now because of this transmission line, what is the impedance you will get? Let's call this transmission line as transmission line 2 and this as transmission line 1. Okay. So Z in for transmission line 1, that was equals to infinity. What will be Z in for transmission line 2? Why it is infinity? Because length is lambda by 2. Now length is lambda by 4. So what will be the formula? Z naught square by ZL. What is the value of ZL? ZL is 0. ZL is shorted, no? ZL is 0. So what you are going to get? Infinity only. Here ZL is 0. Z naught square by 0. So that will also be infinity. So because of the stub, here also you are getting infinity, here also you are getting infinity. That means open circuited only. So because of the stub, you are not getting anything. Are you getting this point? Here we are using stub, but stub is of no use. Why stub is of no use? Because this stub is giving me infinite impedance, this is also giving me infinite impedance, so there is nothing, no use of that. Right? Now because of this lambda by 4 line, what will be the ZPQ? So ZPQ will simply be Z naught square. What is this? Z1 square actually. Z1 square divided by ZL. Are you getting this point? This stub is giving me open circuited, this stub is also giving me open circuited. So there is no use of this stub, only this lambda by 4 line is there. This lambda by 4 line will give me the impedance of, because this is lambda by 4 line. This is lambda by 4 line. Which line is that? Lambda by 4 line. So because of this lambda by 4 line, what is the impedance you will be getting? Z1 square. This is the characteristic impedance. So Z1 square divided by ZL. Z1 square divided by ZL. And that should be equals to what? That should be equals to what? That should be equals to Z naught. Here also I should not write Z naught because this is not your Z naught. This is because of the stub we are writing, and because of the stub it is Z1. Okay. So Z1 value is 75. So 75 into 75 divided by ZL is equals to 50. So value of ZL is 75 into 75 divided by 50. ये गिरेगा भाई 70 112.5. So very simple question it was. This is the answer. I hope you must have got the point that how we are doing. What is the meaning of stub matching and how we are solving these kind of problems. So because of the stub, nothing is coming. The lambda by 4 line is there. You could have directly applied the formula that under root 50 into 75. That also you could have. No. ZL value you need to find. No? ZL value you need to find. So forget about the formula. Just solve by the concept. What is the concept? That Z1 square divided by ZL should be equals to Z naught. Z1 square divided by ZL should be equals to Z naught. So value of ZL you need to find, that is coming out to be 112.5. And another impedance matching we have seen here. So just revise it. Just see how to find out the input impedance. So just you need to apply the formula. What is the meaning of impedance matching? We will introduce a lambda by 4 line, and input impedance should be equals to Z naught. That means there will be no reflection. That is your impedance matching. Same thing we are doing with the help of stub as well. But here stub was not useful. Here this stub was not useful at all. So this was also open circuit. This was also open circuit. For lambda by 4 line, it was Z1 square by ZL. So Z1 square by ZL is equals to 50. Z1 square by ZL is equals to 50. So from ZL value you are getting 112.5. So that's it. This is about your impedance calculation. So I hope you must have enjoyed this lecture. In the next lecture, we are going to study about standing wave pattern. Okay. So standing wave pattern we are going to see. And in EM wave, we have already studied standing wave pattern. When you are studying EM wave, there we have already seen standing wave pattern. So before that, you need to watch that particular video of EM wave. After normal incidence, we have studied standing wave pattern. So that video you need to watch, then only you should come to the next video. Thank you very much.